This meeting is being live streamed. By staying in this meeting, you agree to be live streamed. Thank you, live stream. And there we are. This meeting is being live streamed. By staying in this meeting, you agree to be live streamed.
Oh, I'm hearing some echoes.
Yeah, that's from me. Hold on a second. There it is.
I guess we can see who's joined in Zoom, right? I don't know if we can see who's joined on YouTube.
There might be, I think it just says like N people or something.
Yeah, like, N people watching. Although sometimes that's tripped us up a little bit because we're like, oh, there are 5 people watching, and it's like all Hypar people.
It does not distinguish. Yes, it could be.
Hyparites. That's what I started to call Hypar people. I don't know if it'll stick.
Hyparites?
Or Hyperions. Hyparions.
I thought of Hyparians. That's also kind of hard to roll off the tongue. I keep defaulting to Hypar folks.
Hypar folks.
Hi, people.
People. Yeah, but are
Hi,
we
people.
high people?
No, hi, people.
Hi, people.
There you go. Hi, people. Excellent. And folks are starting to join. We're just going to give just folks a few more minutes to extricate themselves from their previous meetings, obligations, coffee, etc. And then we'll get going. A couple more minutes. We should come up with like a dramatic countdown to the start.
Yeah. 3, 2, 1. Action.
Yeah,
Big explosion.
Rocket sitting on the pad. We can like update it to be a SpaceX rocket or something.
In my undergrad, one of my classmates used to play Final Countdown like on the day of presentations at like something like 5 in the morning.
Oh yeah.
Oh boy.
So, could be something like that.
Right up until pencils down for the charrette. Always a pleasure. All right, I'm going to give it one more minute and then we're going to launch at 3:04 because why not?
On the dot.
And I got to remember to record this, which I will in a moment. All right, let's get started. I'm going to hit the magical record button. Hooray. Exciting. Hi, folks.
Thank you, robot.
Thank you, robot. Hi, folks. I'm Anthony Hauk. I'm one of the co-founders of Hypar. Today, we're going to talk about a little more of an esoteric project we're working on and have incorporated into published workflows of Hypar called Overrides. But we'll be doing it in a rather familiar environment for you. And I just want to talk a little bit about kind of the origin of what you're about to see. When Ian and I started the company in early 2018, it was on the conviction that so much of a building, if you know enough of the parameters, is deterministic that you can actually generate plausible solutions algorithmically. And as you might expect, what we gradually found is, yes, you can do that right up until you want to change that one thing. And then, you know, the experience when you're doing this algorithmically is like, oh, well, we'll add another input. And eventually you end up with this, you know, enormous field of inputs that nobody really understands what they do, and it's not very usable. So taking a step back, we thought about really the way you want to work with a computer is as a co-designer, right? Someone who you have an idea about how something goes together. You want to like tell the computer how to do that, have it do it, and then show it how to do it better. So what Serena and Eric are going to go over today is, you know, to show you that point where the computer gets you 80, 90% there, and then you want to do something without destroying everything that you've already put together, and may want to even keep using the algorithm as you're gesturing into the model you're working on. So with that, I'm going to be quiet. Serena, I think, are you going to start sharing first?
I will be sharing my screen.
Excellent. All right. And
Probably only. I'm just here for color commentary.
excellent. Good. All right. So Eric's in the booth today for us. And he'll be giving you the play-by-play as Serena takes us through the magical world of Hypar overrides.
Thanks for letting me share with you all today. So one of the things that we kind of want to talk about is like the history of overrides and how we got here. For those of you who aren't familiar with what we're looking at, this is something that we're calling Hypar space. We don't have like the best terminology or the correct terminology exactly figured out for what we want to call Hypar space, because Hypar is not space planning, but you can do space planning on Hypar. And this is an example of like one of the more fleshed out things that you can do on the platform. So Hypar space basically was, you know, envisioned by Andrew, who is here with us today as well. And one of the things that it shows very well is kind of this transition evolutionary history of like how overrides like came to be and how powerful they can be. So one of the things that we can see here is it's basically you get a bunch of floors, and then there is kind of this automatic layout of like a couple of cores and a couple of spaces. What ends up happening here is you can go into the space planning zones, or, you know, since that's like there's a lot of information happening here, you can also just click on every space that you would like to change something about, and then change the program type that it is. So downstream functions are basically listening and saying like, oh, if this is an office, then I'm going to lay it out a certain way, but if this is something else, I'm going to lay it out a different way. So if we change the program type here to something like a meeting room, for example, and hit save, we can see that just this one space turns into a meeting room. So the evolution here is that it used to be that we would have inputs for a function. We would say that like everything that I get fed, I'm going to make it an open office. That's how it started, by making all of these open offices. What we can do now is basically start saying like, actually though, I, the designer, or I, the whatever, I know better, and I would like to change this to be something else. So we can see here that this is, well, I chose like a very strange and awkward like room to make a conference room. So I'm just gonna go ahead and like change that to something else that's like maybe a little bit less weird of a layout for a long skinny space. But basically you can kind of see that like, oh, okay, yeah, we can say that this is going to be, you know, this is going to be one kind of a thing, and oh, I'm clicking on the wrong thing, my apologies. And that we also want this to be, you know, something different, and so on and so forth. And this is how we can basically think about we've been using the word overrides, but I personally like to think of overrides as just fancy inputs that you can change by elements. So rather than saying that there's like a global input for everything that like functions do and how the logic is supposed to work, we want to be able to say like, oh, actually, like they vary, and I want to work as a designer in concert with the generative design programs rather than just being handed a black box for, you know, what it is that we want to do.
And I want to linger on just that last point a bit, because what you're seeing here is, you know, generative design happening where all of the spaces were kind of drawn, there were corridors created, there were cores created, and you've got a space layout. But this generative design was very simple and just said, I'm just going to make everything open offices. And this is a case where it's not like our design got us 90% there. It was obviously not correct, right? But it's okay because we're able to have this sort of like human intervention right away. So it's kind of, even this, even though it looks like you kind of have to click every space type and make these modifications, is still like human in the loop generative design, because the generation happens first and the human gets to kind of provide input and direction on top of that, which we think is kind of unique to Hypar in the sense that a lot of other tools maybe are like manual first and then generation gets layered on top. Or there's generation and that's the end of the story. You generate your design and you can take it and then start doing manual edits afterwards, but then you're leaving the generative platform. And so this we think is a unique strength of ours, that we're generative first, and we've added this kind of manual intervention capability through, you know, inputs on elements, like Serena said. You can click on an object and say, this one a little bit different, this one changed the type, and you'll see there are other things we can override, like locations and positions and things, and it's always responding to a generated design that precedes your sort of edits.
Yes, these are really, really good points. And one of the things that I would like to show is, like, you know, the last thing I was changing is, oh, I just want to change what this type of space is categorized at. But actually everything down to the geometry, depending on how, you know, we configure the functions and how like function authors want the logic to work, is configurable. So one of the things that we can also do is we can take this particular service core and we can say, oh, actually, I want to edit this core. I want this core to be enormous for some reason, and I want it to take up the entirety of like this whole section, and then we can just do that. And then so
cores as the primary purpose of a building. I love it.
Yeah, most of the building is now core. But what we could do there then is core by floors. It gave us like a first estimate of like what you might want to be doing. And now what we can do is go ahead and edit what comes out of it. And then basically it runs recalculations and does the appropriate things, taking into consideration what like a human wants to be, what a human wants to happen.
And all the previous edits you had made always persist, right? Generation reoccurred, but your modification of that thing to be a classroom and the bottom bank to be a bank of private offices all continues to, you know, exist and like continue in your design.
Yeah, and that's also, yeah, go ahead.
Yeah, I wanted to interject on that. Like, we so far think this is actually unique to Hypar, this ability to intervene in a generated design, regenerate the design, and preserve all those changes. Now, of course, if we radically change the shape of this building to the point where that meeting room is actually no longer in existence, we're not going to preserve that. Right, there's a certain tolerance for change that the override is going to try to maintain. But the idea here is, you know, the computer should not override the human's choices as much as is possible. And even if, you know, we change the shape of this building, that would essentially be 2 human interventions, one essentially making the second one impossible. So the system mediates all this so that you can arrive at a design that is co-designed with these algorithms to arrive at a good solution.
Yeah, absolutely. And you say that that's unique to Hypar, and I personally feel that it also is, because in so many other programs, it's like, oh, you do the parametric part, you do the, you know, computational part, and then you bake it or you export it, and like, then you have to make all of your edits afterwards. And, you know, I'm really excited to be working on something where we consider both of these factors like all together as well. Okay, so now that we have this, one of the things that you'll see in all of our examples so far is that, okay, like cores. One of the things that I haven't opened a lot is the side here, but you can actually see each one of these is a function. So it's basically a modular piece of logic that talks about, like, what am I going to create and how do I create that? And what are the kinds of things that I need to create this? Core by floor originally took in the size of the core that you wanted. And when you say edit cores, you can basically, click on the core directly to edit it, or you can click on the core here and then edit its shape as well. But up until very recently, we could only say that, okay, if your function makes cores, then you can go ahead and add, you can override what happens with cores. And if your function makes something else, you can override just what happens to that other thing. And one of the things that we started to realize is that a lot of functions depend on, they want to vary, not based on the thing that they create, but based on something that they depend on. So one of the things that we started to add now is the ability to do what we call cross-function overrides. And again, these are not words that I hope stick around, but the idea for cross-function overrides is basically, I want to set this to vary based on one of my dependencies. And I would and I think of cross-function overrides, again, all overrides is basically a fancy form of input, and overrides are basically inputs by element. So as an example of that, I will add a function that I just created earlier. So I hope that everything works great. So if I add,
this is fresh functionality.
Yeah, fresh functionality. I hope I didn't make any bugs. Okay, so if we go into exit stairs now, we see, and I'm just going to go ahead and permanently hide core by floors. So what does the logic of exit stairs do? What did I, the function author, basically say that I wanted it to do first? It just creates an exit stair in every core. That's its job. And so,
Serena, how do you decide how big the exit stair should be?
Oh, great question. Well, you'll see that I have pulled up here the IBC, which I'm not going to make everybody read here,
because you're going to read it to us.
But I thought that exit stairs was kind of a nice example of a real world problem that is complex enough and has enough going on that it would really benefit, as many if else's and as many things as we want to be able to support, we may not know the entire code or have understood how to apply it in every scenario or whatever, and could really benefit from overrides.
Well, I'll also add, this is the kind of problem that Hypar wants to solve in general, because it's formulaic, even though it's complex and it requires you can get better at designing exit stairs, or you can have certain expertise in this. It's a formulaic complexity. And if you understand the code and you understand your building, you should always come up with basically the same exit stairs.
Yeah, I'll jump on that point in particular. So way back in the dinosaur age, when I worked at architecture and engineering firm, we had a guy who did fire stairs. That was his job, because he understood the code so inside and out that's what he would just do every day. I really want to give that man a better life. He should not have to draw fire stairs anymore.
Right. And this is something we can automate, because there are procedures that need to be followed, given certain shapes of the building and certain properties of the things that Serena is going to get into. You can have something that will tell you, you said you wanted exit stairs like this. Here they are. They are sized correctly for you according to certain properties.
And and some of the kinds of things that go into how big your exit stairs are required to be are, as an example, occupancy group, which is basically a proxy for how hazardous is this building, and how ambulatory and capable of self-preservation are the people who are in it. Whether or not the building is sprinklered a certain way or has certain kinds of fire protection. How many people are there? That's one of the biggest ones. There's also just absolute minimum dimensions that are specified in the code, whether the stairs are accessible, so on and so forth. I did not include all of these things even a little bit, but I do have some of them in here, so we can take a look at how that works. So one of these things that we can see right now is I just added this exit stairs function. And this star means that a function came with additional messages that it wants you to know about. So what are the messages that are here? It says an area factor, I don't know if people can read this or if it's too small, but it says an area factor of 150 for business use has been applied by default per table, whatever business area is. So basically it's saying, I took a guess at how many people are in your building. But that might not be how many people are in your building. So it's just warning you, like, this is a guess, you are responsible for the outcome. And to make my life a little bit easier, actually, no, I think I can still do this. So what happens then, so it says like, oh, okay, the occupancy per floor right now, this particular floor has an occupancy of 155. If I change the occupancy to something like very large, we should see that the exit stairs get bigger.
And that right there, hidden just in that little dialogue, is a kind of cool moment where floors didn't used to know about their occupancy. But when you add an exit stair, and maybe we can see that real quick. When you add exit stairs,
and when you click on the floor, you get nothing. Yeah.
That's it. Floors are just like, a thing that was created by the floors by levels function. And they're there. They're right. They were created based on their sort of upstream inputs. But now with exit stairs back in there, exit stairs care that floors have an occupancy. And so in the style of fancy inputs, exit stairs said, one of my inputs is an occupancy for every floor. And so now floors have this kind of additional capability, this additional data on them.
Yeah, and I'll add there's another subtle advantage going on here, that the developer who made floors by levels didn't have to like offer source code to have it modified by somebody else to make sure that occupancy could actually be calculated using the floor. So later, and something developed completely independently can now add those kind of pieces of information that are critical to make these calculations without affecting the original component. So it's not like, say in Revit, where you've got a family and like, oh, we didn't put that parameter on, let's put that parameter on, let's share the family around. This is all coming in ex post facto into the workflow so that you have a much smoother experience. You're not like petitioning Hypar to add some extra information so you can make this calculation. You can write your own function that does it.
We actually have a question in the chat about how this works. And just FYI, Andrew, you're responding in the chat really nicely, but it's only going to the panelists. Anyway, but the question
Our
is,
Andrew.
Different Andrew. So basically the question is, do downstream functions then affect upstream functions? Kind of. So basically, we do not consider downstream functions to have ownership over upstream functions. Therefore, if an upstream function says like, my floor thickness is, like, I don't know, 6 inches or whatever, a downstream function cannot say, actually, I think like this floor has to be, a different depth, right? What the downstream function can do is say, like, I require information that's not inherent to this floor, like, please give that to me. So we think of the downstream function modifications as being additive, like making the data richer rather than actually modifying what comes out. Because again, as you saw before, floors, so if I remove exit stairs again, we can see that like, these are all the properties that exist on floor. Floors do have a thickness, a profile, like where they live in space, et cetera, et cetera. They do not have occupancy. So the occupancy was additive basically by exit stairs and are not a modification of something that like the floor itself was supposed to set, if that makes sense.
It's a great question and a good observation. Like, how are we going back up there? We're actually not. We don't have to go up to floors to modify them because, as Serena said, it's adding information only.
Yes.
And this is kind of an important element of the customizability about Hypar. If you have, let's say, part numbers that you only use within your organization and you need to associate it with floors in this case, but I think let's say columns instead. You can start having subsequent functions inject additional information, those part numbers, using our standard column function without you actually needing to modify that column function. So as always, Hypar is very composable into new use cases.
And a great follow-up question on the chat is, then that means that the information isn't necessarily available to another function that might also need occupancy. Great question. We are thinking about this problem for sure, and want to make sure that we do it right. Our very first stab at this in the current moment that is available is that a function can request something, consume it by itself, and then discard it. It is also possible for, if you know that like exit stairs requires occupancy, like you also require exit stairs, and you can go and look up in exit stairs, like basically what the value that it assigned to occupancy was. Obviously, this is not ideal because, there's many functions that might require occupancy and they can't all sort of circularly depend on each other. So this type of property addition is something that, we're considering, like, does it mean that floors, that all floors end up getting an occupancy? Does it mean that we have some kind of like an intermediate, step? That is a problem that we're working on. So.
And things will continue to evolve. Right now, there's no occupancy on floors, but like Serena says, we could always add that. That could be just an inherent property. Or like if we see a lot of recurring use cases and a lot of like duplication of a particular override, well, that's the case where, maybe there's another function in the stack. Maybe there's another like kind of thing that's responsible for managing occupancy properties in a more nuanced and like global fashion. But this gives you as a new function author the flexibility to not have to know about any of that. You can just say, there are floors, this is the data I care about, and start solving your problem.
Yeah, absolutely. So a couple of other things I was going to show about how like the overrides work, and there's a great comment also in the chat going on about like modification stats, which like, we do not demonstrate exactly, but we do have a kind of a hint at. So one of the other things that's inside of this like big long piece of text is if your building is not group H or I2 occupancy and is sprinkled a certain way and has certain blah, 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 you're allowed to use a reduced width factor. So one of the calculations in the code is, for every n people, you need like a certain number of inches of width on the stair in order to make it compliant, in order to qualify as like this stair can carry this many people in an emergency. And so you are allowed to use a reduced capacity factor if your building is like sprinklered and like has these certain systems a certain way, because they assume that like your building is safer and it's okay if it takes people like a little bit longer to get out, or it's like things aren't as wide. So one of the things that we should see is that this is a slightly smaller number than the default. And if we say that like my building is sprinklered, we can now see that they're a little bit smaller. And one of the interesting things that we can also see is that if you click on a stair and expand all of its properties, this function keeps a history of like why the stair is what it is. So it first says a width factor of 0.2 was applied to the due to sprinkler system status. So if I didn't have, so basically if I like turn this back off, we will see instead that this line says, applied a factor of 0.3 to a load of 450 occupants. And it needs to be 135 inches minimum. But now there's also like another check that it needed to do. It says that the calculated width does meet the 44 inches required in order for your stair to be considered like an accessible means of egress. So basically it like, there's a step in it, right, where it says, okay, like your stair needs to be this wide, but it also at a very, very minimum needs to be this wide. So if I go back to the occupant load and I basically make it something like very small or much smaller, we should now see much smaller stairs. But more importantly, we can see It did apply a width factor of 0.3, and it says that you need a 23.4-inch minimum stair. However, the width was increased to 44 inches for, which is the minimum required for accessibility. So then what you can do now is like, one of the things I didn't include is that not all exit stairs have to be accessible, and there's a bunch more, hundreds of other rules that are like, why? So I, the function author, did not take like the best guess because I don't know the entire code yet. And so you, as the designer, you can know better. You can say, I don't need to apply a 44-inch minimum. I can go into my stairs override and I can say that my minimum tread width, oops, I don't like meters. So I'm going to go ahead and like make my units feet since the code is in feet. So I'm going to go back here again and say, okay, the minimum tread width, this is basically 44 inches, right? But like rounded weird because feet to inches. Anyway, so I can say that I actually want my minimum tread width to be 3 feet only. And so if I save this again, what we can see is that only applied to this particular stair. It was not a universal thing. I just said that this particular stair is not accessible, or for whatever other reason, I decided that its minimum needs to be 36, and applied that here only. And then what we can see here now is, again, it continues to explain to us, like, it applied the width factor of 0.3. It was increased to be a minimum of 44. It applied an override with a minimum stair width of 36 inches. So then it checked the factor again and then turned it back to 36 per user specification. So this is kind of like, it's not quite a stack, but because we have all of these like different reasons that something can happen, like, and one of the reasons that something can happen is that like the designer knows better. We can go ahead and keep track of all of this for you, and you can also understand, where something came from generation and where a decision came from a user, rather than like sort of a black box generative first guess at your solution.
And I think this is perhaps worth highlighting something that's also been said in the chat. The interaction here is actually very fluid from a user point of view, which I think is really, really cool. Like, this is generative design first with, code and logic embedded inside it, but with the additional capability of you click the stairs and say, no, I wanted them to be 36 inches. And like, that's just what happens, And not only that, Serena, something you've added here that we haven't seen a lot on the platform, but I suspect we will see more and more versions of, is this idea of the kind of logic stack, which I think is really cool. Explaining how did we end up where we are. There was a lot that happened internally, and we want to expose to the user. We always want it to be clear to people, why are things the way they are inside my design? Given that there's this sort of interplay between this function and other functions and augmenting data, and this function and you as a user. But the actual interaction is very, very clear now, I think, which is kind of sweet. Click on thing, make modification, be told little story of how we got to this width is pretty nice.
Right. And again, these are all things that persist, right? If I take this stair and I say that I wanted to actually move it from, here to over here somewhere inside the core, I didn't like where it was before. The logic stack sticks with it. It remembers, like, this is the stair that I had wanted to do something else different with than this other stair, for example. So so basically it kind of allows you to track decisions and to also track like automation and how how we work in concert and how well we work in concert. And and I think that that's something that's pretty exciting to me, at least. So, yeah. And then I'm going to move over to localhost, which is very developer of me. But we have some things in flight that Andrew's worked really hard on that I'm excited to show. Yeah, so it's not available yet on Hypar because we are testing it internally, but I couldn't wait to show it off, so I'm going to move there now. Just go here.
This is very exciting. Talk about previews. It's about as bleeding edge as it gets.
As bleeding as it can get. It's not even here officially. So so this is just the same workflow, but hosted by me now. And if I go back into my favorite, which is Ortho Mode, one of the things that we can see that are now being added to overrides, besides just the ability to edit them, is like, what if I didn't want this core at all? I decided that I want to delete it. And what happens is like, voila, you can see that one core existed. I'm not sure if people noticed that it got, whether it changed size, but essentially, actually, I'm going to try this again to make it a little bit more obvious. So if we go to make the size of this bigger and say save, and I can say, here's a very large exit stair right here.
That should get the job done.
Two
Substantial.
of them. It might have gotten a little bit confused by what I just did. I wrote this like earlier today, but in theory, that would be me as a developer error and not a platform issue. But in theory, basically, if I was to say edit the occupancy again to something very large, and have my big fat stairs, if I delete one of them, the other stair gets much bigger. Now, nobody would actually want to build this. So obviously this is something that, oh, actually, I don't want that. And in fact, I don't want to put a stair in my core at all. I want to put it, punctured straight through this desk for some reason. You can also go ahead and add that as an override as well.
You're the designer, you know best.
You're the designer, you know best. I want stairs everywhere.
And so the feature being highlighted here is even fancier overrides, or even fancier inputs. So overrides has evolved not beyond even just being fancy inputs that are attached to elements, to being standalone creation of elements on its own. So this function that creates stairs can now allow the user to create stairs kind of out of whole cloth without even requiring a sort of generated object to start with.
And the exciting thing about this that we've sort of been talking about internally is that, we start from this generative first idea always. And so what we could have done as a platform is we could have just started out saying, everyone wants to be able to model, so we're going to make a modeling program. And in my modeling program, I can create columns, I can do this other thing. But we didn't tackle this, like Anthony says, the Hypar was started years ago, and we didn't tackle this issue really until now of like how to seriously add something, something new, how to model basically on the platform. And it's because, this has allowed us to think about addition and deletion and these other such basic tasks as something that will work with the entire ecosystem of but how do we know which is which? How do we decide that, this stair is this stair after somebody has moved it? How do we know, if somebody has moved it, has changed its shape, has changed its name? Like, what is the true identity of the stair, and the true identity of a stair versus a room versus a desk or whatever? They're not the same thing. And so this, the way that we've been thinking about this is that, yeah, you create a generative design first. Then actually you want to change your variables and your inputs by element. Actually, if you want to change them by element, you might actually want to be able to add and remove elements as you do this, and so on and so forth. So yeah, this has just been a really rich experience of how to think about design where, where the generative program basically respects the intent of the designer, and how it can sort of augment decisions, provide feedback, do certain kinds of checks for you, analyze, give suggestions, but not be in your way. That you don't have to, like, we can see in my interaction, I'm still directly clicking on things. I'm still, saying like, I want to add this. I'm still saying whatever. So it's not necessarily that, because it's all complicated deep down, that it needs to be complicated for you. And I think that simplicity has come out of basically not solving this problem first before we thought about the other kinds of constraints involved in generative design.
Yeah, I mean, this is also a sign of the sector we're working in, right? I mean, if we were designing phones here, we would set up the algorithm to stamp out the phones, and it would make a million identical phones. Where of course, the contrast with buildings is we have a lot of identical components, and they get assembled in 1.5 million different ways, even in a single building. So we wanted to make sure that the computer was helping you, not fighting you here. And that's why a lot of this functionality is in here. This is the result of a lot of conversations with many customers about how they want the computer to help them, not turn into their adversary as they're trying to get to a solution they know is correct.
So I would say that is the last of the initial demo that I had planned for today. But we would be really interested. We can blather on about how big of fans we are of overrides all day and how they are the inputs of the future for us. But we'd also be interested in getting feedback and questions or comments from our attendees. So we can.
Yeah, anybody feel free to type questions into the chat. I don't know if we have any Hyparites watching on YouTube to see if there's any questions, but if anybody sees one, let us know. Also, if you want to ask your question live, I've got these allow to talk buttons that are just waiting to be clicked on. So feel free to raise your hand if you want to be recorded actively.
Yeah, if you would like for your voice to be immortalized on YouTube.
So one of the things maybe I could ask about is, I feel like we've alluded to it, but we've called them fancy inputs, but I think you also just said, Serena, the new style inputs. What other thing has this allowed us to do, with vis-a-vis the old input panels?
Oh yeah, one of the things that I can actually show, and if I go back to sharing my screen, one of the things that I can show is that how this may differ from the kind of combination old style inputs / new style overrides. And I'm just going to remove this for a second to make it easier for us to see. So if we go to space planning zones, we can see that the default program assignment is OpenOffice. So a user will come here and say, actually, if I want for everything to start out as a meeting room for some reason, because nobody wants to work at a desk in my particular building, you can do that. And so what you'll see is that it makes meeting room the default thing that happens inside of this building. Obviously, there's like weird meeting rooms, and I'm pretty impressed, Andrew, that like these are doing as good of a job laying out furniture in these strange spaces as they are. But the point is that
it's not creating like the banquet hall of my dreams, but it's
it's doing like something reasonable.
Well, there is a way to make it less weird. Of course, you could actually just scroll down a bit and split that zone a couple of times, which is yet another kind of fancy input.
This is another kind of fancy input. Yes, I can say. Yeah, I don't want, I want my rooms to be smaller. And then we should see, I'm not actually, yeah, here we go. So now we have 3 times the number of desks, or
perfect.
Or actually, no, we should call this 3 times the number of collaboration points. But the point is that, but you can see one of the things that did persist, right? We had said that this was a classroom, and we had said that this is going to be private office. And even though I changed the default for the entire function, it remembers though, like the user's input is more important than my assumptions. So it saved this for us. But the new thing that is happening here inside, oops, I had gotten rid of exit stairs, so we can just bring that back. Exit stairs, as you can see, besides the are you sprinklered a certain way question, which is universal to the whole building, it doesn't have, give me the number for your default occupancy. It is able to, it's able to figure those out on the fly. It's able to not ask you for any kind of a default input. And if it had more default inputs, such as like, 2-hour wall or however many hour wall or size of door or whatever, it would also be able to just calculate those on the fly. And like, you don't need to duplicate this type of input between overrides and between our traditional inputs. We are having a hearty discussion, within the company about like, is there still a place for default inputs for you to always go there, or can we just like be generating defaults within the function? But currently, the function is taking its best guess, and we are generating defaults inside of the function for people to use. But that is something that if this is successful enough, rather than having functions with very, very large, for example, custom levels is actually a perfect example. Before we had such powerful overrides, custom levels was built for you to be able to say, I want levels at this height. And it does this by saying, this is the height of my basement, this is the height of my ground floor, the typical floor is relative to the last one, and then I just want to repeat this until I get to a penthouse. This is not a tall enough building for all of these things to come into effect. But the point is, we're managing this through lists. And we are actually considering also at this point moving this crazy panel into just being inputs, where it just guesses what you want your levels to be, and then you can start to just click on what comes out, override where you want your levels to be, change your logic there, change the names of your levels there, etc., and basically have a much more intuitive user experience, and one that people enjoy using more. Nobody has reported to me that they love this list. So
well, and along that idea, nobody loves that long list style input, and a term we've used sometimes, maybe even externally, is the jet fighter cockpit problem of some of these generative tools, where you have all of these options that you need to set, right? Here, you have to like describe your building and what you want in text and lists and numbers and sliders and this whole thing that are totally removed from the design itself, right? We're thinking about how this can actually move a lot of that problem into the 3D model, and take those inputs and put them where your design is. Take your design choices that happen by clicking on a specific object, and narrow that jet fighter cockpit down to just the decisions that are actually relevant to the things you're looking at. And I think that touches a little bit on one of the questions in the chat regarding, could we have nested generative design in kind of like smaller and smaller pieces? In addition to Andrew's comments, for sure, one of the challenges with making something like that has this sort of like nested generative design is the number of inputs starts to expand wildly, right? If you're having generative design occur on a room by room basis, how are you supposed to sort of like manage and understand the number of inputs, the number of like sort of like human intentions that are trying to be captured in the generation process? But by bringing these sort of fancy inputs to the elements, by having generation occur from data, from inputs that occur on an element by element basis, we can kind of zoom in. We can say like generation occurred for this space, given this piece of information. And how do you access the generation information? Oh, well, you click on the space and it tells you everything about how it was generated and the other things that have been generated in response to this space's existence and things like that.
It makes the design contextual. I think how many times, let's use the sort of one of the older varieties of parametric design, and one that a lot of people are familiar with, the Grasshopper Script. How many inputs in your Grasshopper Script do you have, and are they, do you click on an element there and say, actually, I want to change, the color of this one, or I want to change something about this one? You can't. The only thing you can do is have more and more inputs at the front of your script. You can only say, oh, okay, yeah, box, second box color, first box color, whatever it is that like everything that you need to do has to be global. Inputs needed to be global. Anything that's not calculated needs to be global, and what we can, and that starts to get also this like issue of the, this, what do we call it? cockpit.
The jet fighter cockpit,
the
which is,
jet
I don't
fighter
even,
cock-
I've never been in a jet fighter, but I just keep saying this like I know how complicated it is.
Yeah, exactly. And so the jet fighter cockpit then experience extends when you need to control things at a very granular level, but you're not allowed, well, you're not allowed is not the right word, but you're not able within that that environment to select only the things that you care about for partway through the design. And I think that that's like another really important thing, right? Our only options for that in the past would have been, oh, I know that at this point I might want to change something about these outputs. What do? You create a new script that does step 2, right? And then you keep step 1 separate, and then your workflow is I do step 1, I bake, export, whatever it out, I edit all of these things. Step 2 pulls in the overridden elements that come from step 1, do some more things, and then that script ends when you think you might need to change something else. So what we've done here is kind of made that process very surgical and very seamless, where you don't have to pause in Hypar, go somewhere else, come back here with like all of your new things and do this whole import export process. You can just use it as intended, and it only shows you what is relevant to the thing that you're looking at. And we're really excited to be moving in that direction.
And partly that comes out of generation being the sort of core experience. Like, this is generative design first. And so when we wanted to generate something on a more granular scale, we're able to kind of like add in those details after the fact, instead of generation being not an afterthought, but being something that's kind of like maybe bolted on to a lot of other tools, where in the workflow Serena just described, if you go through that process and you realize you need to change something all the way upstream, you have to go through the whole thing again. But normally there's some sort of highly specialized user who's responsible for doing that, right? Like, managing the generation process becomes this like, the special priesthood of computational designers who are like, the keepers of that process. And when you go all the way upstream to make a modification, you start walking your way back down the entire thing manually again. You're manually running your automation.
Yeah, and there's an interesting question on the chat that is, could the smaller scale of generative design be relegated to, for Revit smarter families? Actually, now that I parse that, I'm kind of curious what we mean for smarter families. If somebody, I think Andrew's been responding, can clarify.
Yeah, I mean, I understand this question as just being about, the idea of a sort of small scale automation is really basically what a Revit family does. A parametric Revit family says, okay, given a few inputs, parameters, controls, I'm going to generate some geometry. And the level of flexibility there, I mean, people make insane families. But like most families, it's like, okay, I've got a table family. Does it have 4 chairs or 6 chairs or whatever? Yeah, exactly. That kind of thing. And so I think, Hypar definitely operates sort of system down to object rather than object out to system. And I think that's one of the really distinguishing features. And overrides is sort of us backing into the ability to operate at the level of the kind of object level settings. But I think absolutely a Hypar function can work like a Revit family, or like the logic of a Revit family, and that it's basically responsible for producing some geometric result, some BIM information based on some set of parameters, which can be, and this is the part that's cool, not just the inputs, not just a few numbers or parameters you can set, but also contextual. It can make decisions based on the position of other elements in the model or its relationship to other systems that exist. And like setting that up with custom behavior in Revit is nigh impossible. So. And
one of the things that I'm excited about this is actually, it kind of works at the whatever level you want, right? We have, we have all of these functions that are specific to space types. There's, I'm not sure if we saw this here, but for example, we have all these different functions that do a classroom layout. If there was like a different function that also did classroom layout that was competing, we could just swap that in and out and say, I'm going to use this other classroom layout function. I'm going to have private office layouts. I know that that exists. And then you can kind of add modularly. So each one of those functions is only responsible for the kind of thing that it does. And it doesn't have to care about how desks are laid out in OpenOffice. It doesn't have to care about any of these other kinds of things. It can just think about its own little piece. So you can write a function that just takes, like a square or a polygon and says, this is a meeting room. Decide how your meeting room wants to. Oh, I want my meeting room to have bookshelves and some plants and whatever else.
And
fancy meeting room, elevated meeting room. Yeah.
speaking of which, I own this office and I have many cats, and I think they should have their own room.
Okay, so
What does Hypar have to offer?
just for fun, this was an experiment, but there is a totally probably not that useful function on Hypar called cat tree. And basically, yeah, so there's all these pre-baked, normal people program types that are in here, but I happen to know that cat tree needs a room to be assigned as cat tree. And so I can assign cat tree to this room, and then I can hit save. And then so this particular function, all it does is makes a cat tree in a room that you give it. Or does
Oh
it?
no.
Oh no, some warnings have occurred. Solution, blah, 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 blah. Well, maybe it did not like this particular room.
Come back later for more cat tree.
Come back
Stay
later
tuned.
for more cat trees. Actually, that's the first failure I've gotten with cat tree. I wonder if it's all of them. 1 second. Well, I will stop share so that I don't get self-conscious while I try to figure out how to get my cat tree to work. But basically, the point is that I was trying to make a new space type. I was trying to learn how to use Andrew's new spiffy Grasshopper 2, which is a much better and improved version of how to write functions on Hypar with Grasshopper rather than C# or Excel, which is other function types that we allow. So for those unfamiliar, you can put logic on Hypar in many different ways. And so exit stairs was written in C#, but cat tree, if I can get it to work, it was done in Grasshopper. And so what that is going to allow us to do is to have all of these functions written in the language that and logic and according to the strengths of whatever it is that they're best suited for. So I'm going to try cat tree again and see what happens. But I will pass. But I was trying to make a larger point, sorry.
For what it's worth, I do have cat tree working in my floor plan, if you want to show it.
Show us the cat tree.
Okay, 1 sec. It's very dense in there. This is a lot of cats. But
I am, in fact, a cat entrepreneur.
So I took this space and I designated it as cat tree, and it has created the world's most incredible cat play structure right in the middle of this office. So we can jump in there and see all of my little low poly cats enjoying really the time of their lives in the middle of this office. So this is Hypar HQ's future, I think.
Right.
That is true. A lot of us do own cats. But yeah, so but we can think about that at the level of granularity of just a room. And within the room, you can think of it at the level of granularity of just a chair. You can override like the positions of individual chairs and tables in Hypar, and then you can override how many occupants there are per floor. We can go all the way from, where we're now pushing the bounds of what if you go all the way down to the chair, but you actually also go all the way up to an entire master plan campus. We're not designing Hypar for any particular scale of problem, just design problems in general that have constraints and that also are complicated enough that we're not going to get the right, like automation is not going to get the right solution, but can help a lot along the way.
So there's a question here about, what our goal is perhaps with Hypar in a broad sense, and whether we're trying to replace other tools that exist. And I want to just highlight, Hypar is on the same page in this regard. We want to make better buildings, and we think there are important things that need to happen to make better buildings exist in the world, including better tools for designers, right? Make tools that help designers make better buildings would be a sort of short-term mission for Hypar, and the long-term quest of just making buildings better, right? The built environment desperately needs expansion and improvement. But with regard to Revit specifically, we do have on our YouTube channel some tutorials about this, and also we've done a Hypar Live about this topic. And it's not the last time we're going to talk about Revit interop, but we do have pretty, I would say, very capable, if not incredibly fleshed out Revit interop tools. We've got a free add-in that you can use. You can both go from Revit to Hypar for context, and there's a lot of good videos about you doing that for Hyparspace in particular. And you can also take an entire Hypar model that's been generated and load it into Revit, and at various resolutions, from just kind of visualizing your results if it's analysis, or you're not really sure that you're ready to bake the design in Revit, all the way to your native Revit families from your company's template could be generated and used on Hypar, and then completely imported into a Revit model that's ready for the rest of the documentation and design process. So everything in that range is possible, and it's also under active development.
Okay, I think we're reaching the end of the hour. If anybody has any last questions, I'll give it a second. Okay, so we need to get to our happy hour, which starts Friday happy hour at Hypar. And so thank you all so much for joining us today. We've appreciated all of the really thoughtful questions. And, we would love it if, I'm sure a lot of you are already on our Discord, but, join us, keep having conversations, keep showing up for Hypar Live. Yeah, we're just excited to have you. And I'll let Anthony finish out.
Okay, and tell your friends that we will shortly be posting this session on our YouTube channel, which I've dropped into the chat. So we hope to see you at future sessions, and please try out Hypar for free. All right. Thanks, everyone. Have a great weekend.
Thanks all.